Hello and welcome to the Group 15 Galaxy Project. In this video, we'll be analyzing some of the characteristics of galaxies and how their classification depends on some of them. Specifically, we are interested in studying the relationship between the classification of galaxies as either spiral or elliptical and their mass to light radius ratio, using the ratio of the log of the mass to the radius of 90% of its light. In simpler terms, we will take the mass and then divide it by the radius of the galaxy. This number will then help us classify it as either a spiral or an elliptical galaxy. We began to look at images of galaxies to see which classification, spiral or elliptical, might be more likely to have a higher ratio. In the picture you see, there is a lot of blue. These represent very new, very massive stars. This spiral galaxy also has a very clear edge to it. This leads us to believe that spiral galaxies tend to be more massive and have a smaller radius. Elliptical galaxies, on the other hand, tend to have older and smaller stars, since they tend to be redder. Also, they have no clear border to the galaxy. Therefore, we can assume that elliptical galaxies tend to have smaller masses, but larger radii. The specific question we wanted to answer is, we expected that at least 80% of the galaxies whose ratio lay in the top 20% of largest ratios would be classified as spiral galaxies. Based on what I said before, if we take the equation of the ratio and increase the mass and decrease the radius, this follows the characteristics of a spiral galaxy. So a larger ratio should represent a spiral galaxy. The histogram on the left shows the frequency of the values for the ratios we calculated. We can see that although the data is slightly skewed to the right, because the data set is so large and the skew so slight, we can treat it as though it were symmetrical. We then use the mean from our statistical summary to calculate the 20th percentile value for the ratio. Looking at the z-score necessary, we were able to calculate that the value of the 20th percentile is 2.138. In this histogram, we can see the top 20 percentile I just mentioned, plotted against the percentage of people who thought they were spiral. This means that the right side of the histogram represents whether or not the galaxy is spiral. But as you can also see, the graph is skewed to the right. This means that there are very few galaxies that are actually classified as spiral galaxies in the top 20th sample we took. With the data we collected and analyzed, we were unable to support our hypothesis, nor were we able to prove or even see a correlation between the ratios and what the galaxy was classified as. We used the data that displayed the top 20% of galaxies with the highest ratios. We could observe that only a very small amount of those galaxies were classified as spirals. If we were to do further research, we would analyze the top 20%, but focus on the galaxies that were elliptical in order to see if there was a stronger correlation between the ratio and their classification in that regard. We expected that the spiral galaxies would have the highest ratio, but not only was this not the case, but we found no observable correlation in the classification of spiral galaxies and the ratio. We learned a lot about how important data is to conducting research and answering research questions, that one must be careful when it comes to working with data. We made an assumption, and then we realized, once we looked at the data, that it was wrong. This Galaxy project helped us understand a lot about the nature of science and data collection. For example, we learned how important it is to have many samples of data. We wouldn't have been able to do this if we didn't have an enormous database of galaxies with which to analyze the numbers. We also learned the process of hypothesizing and sometimes being wrong. You have to have an idea and then analyze the data and see if it's right.